All right, this is part 2 for lesson 10, radiation. If you've watched and practiced part 1, now you can move on to part 2. In lesson 1, we learned about what kind of atoms emit radiation. And you learned that an unstable nucleus is what emits radiation. This picture shows us an unstable nucleus. It's really unhappy. So you can see that the unstable nucleus emits radiation. And then the nucleus becomes happy. Or we like to say the nucleus becomes stable. So if we have an atom that is unstable, okay, it's going to emit radiation. This radiation can be alpha, it can be beta, it can be gamma, and we're also going to discuss a new type of radiation called positron. Let's begin our discussion with alpha. Let's start with alpha emission. Let's call this alpha decay. If you recall, alpha has a symbol of He42. So if I have an atom like uranium 23892, this is the mass number, and this is the atomic number. Okay, you remember that from term 2. Now, if this nucleus is going to undergo alpha decay, I'm going to put an arrow, and I'm going to show how this nucleus is going to change. Remember, this nucleus is really unhappy. So it's going to emit radiation. In this example, the radiation emitted is alpha. So I write He42. Now, what happens to the new nucleus? The new nucleus is going to be stable, but it's going to be a new element. Okay, it's going to be a new element. Now, the new nucleus is going to have a different mass number and a different atomic number. So, the mass number was 238. This number is going to decrease by 4. So it's going to be 234. The atomic number was 92. It's going to decrease by 2. So the new number is 90. Now, we have to open the periodic table and see which element has atomic number 90. Let's open our periodic table and check which element has atomic number 90. Oops. Oops. All right, let's put it on a different page. That way we can see it really good. All right, that's good. All right, let's look for atomic number 90. And here it is. Do you see that? The atomic number 90 is TH. Don't worry about this number. This is the mass number. This number can change. Let's go back to our problem. So atomic number 90 is TH. So this nuclear reaction looks like this. All right, let's do some practice. Can you complete the nuclear reactions below? Pause the video and try to do it yourself. All right, are you ready? Now, this is alpha decay. So anytime we have alpha decay, we must put He42. This is alpha. Now, the top number, which is the mass number, is going to decrease by 4. So 157 minus 4 is 153. This number is going to decrease by 2. So 56 minus 2 is 54. Now, let's open our periodic table and see which element has atomic number 54. Here it is. Xe has atomic number 54. So we put here Xe. Next one. Also alpha emission. So we put He42. Now, this number will decrease by 4 and the atomic number will decrease by 2. So 127 minus 4 is 123. 53 minus 2 is 51. Now let's go to our periodic table and see who has atomic number 51. Here it is, SB. So you can put here SB. And now we are finished. We have completed the nuclear reactions for alpha decay. You can check your work by adding the numbers on the right. They should equal the numbers on the left. So 153 plus 4 is equal to 157. 51 plus 2 is equal to 53. Oops, no it's not. Oh yeah, it is. Okay, sorry about that. All right, everything is correct. Let's move on to beta. In beta decay, the symbol was E0 minus 1. Let's look at an example problem. Here's carbon 14. Carbon 14 is an unstable nucleus, so it's going to emit beta. So after the arrow, we write beta. Okay? Plus, you have to figure out what the new stable atom is. This top number, 14, stays 14, changes by 0. Okay? This bottom number 7, we're not going to minus 1, but we're going to add 1. So this is going to be 8. Then you need to open the periodic table and see which atom has atomic number 8. There it is, oxygen. This is oxygen. Now let's check our work. Remember, what's on this side should equal what's on this side. So 8 minus 1 equals 7. So you are correct. Move on to the next page for some more practice. Go ahead and pause the video and try to complete the equations below. Okay, let's check your work. Beta decay. Beta decay means an electron is released, so it's going to look like this. E0 minus 1. E0 minus 1. That's beta. Okay? Now, this number is going to remain unchanged. So I'm going to put 41. This number is going to increase by 1. So it's going to be 21. Now, you should go to the periodic table and you should see atomic number 21, SC. So I'm going to put here SC. There's our answer. Second one. This top number, 27, is going to remain unchanged. 27. This bottom number is going to increase by 1. Let's open to the periodic table and see atomic number 14 is which element. There it is, Si. So we're going to put here 14, which is Si, silicon. Now, if you're feeling a bit confused, you should check your work. Okay, let's see. This number, this number plus this number should equal this number. So 21 minus 1 is equal to 20. 41 plus 0 is equal to 41. 14 minus 1 is equal to 13. Everything is correct. Next is gamma decay. Next is gamma decay. Gamma radiation has a symbol of like a Y. Sometimes we even put here a 0 and a 0. So if this unstable atom is going to undergo gamma decay, it's going to release gamma, like this. This top number is going to remain the same, 238. This bottom number is going to remain the same, 92, and the atom doesn't change. Gamma decay is very easy. Everything stays the same. Let's practice gamma decay. Pause the video and try to complete the questions on this page. All right, are you ready? So this is gamma decay. So gamma looks like this. So both of them are releasing gamma. Now, because both of the numbers, mass number and atomic number, do not change, the products will be the same. So the answers for the reactions looks like this. Easy? All right, the next one that we're going to discuss is positron emission. Positron looks like this. E0 plus 1. Positron is a positive electron. Don't confuse it with beta. Beta is E0 minus 1. This is E0 plus 1. So if this uranium atom, which is really unstable, is going to emit radiation, it's going to emit a positron, E0 minus 1. You need to figure out what the stable atom is. This number, positive 1. This number remains unchanged, 238. This number will decrease by 1. Atomic number will become 91. Now let's look on the periodic table and see atomic number 91 is which element. Here it is, Pa. So we're going to write here Pa. Now you can always check your work. Remember, what's on this side should equal what's on this side. So 91 plus 1 is equal to 92. That's how you know you did it correctly. Now let's practice. Go ahead and pause the video and finish these two equations below for positron emission. All right, have you finished? For positron emission, we will show E0 plus 1. E0 plus 1. This means positron. Now, what's the new atom? This number will remain unchanged, and this number will decrease by 1. Now, let's open the periodic table and see atomic number 5 is which element? Boron, B. Second one, this number is unchanged, and this number will decrease by 1. Let's open the periodic table and see which element has atomic number 13. There it is, aluminum. Now remember to check your work. What's on this side should equal what's on this side. So 5 plus 1 is equal to 6. You are correct. 13 plus 1 is equal to 14. That's how you know you're correct. All right, almost finished. Last one. All right, the last one is electron capture. Electron capture is a little bit different from the others, so make sure you star this in your notebook, okay? Electron capture is when you have an atom, for example, carbon-14, 6, and during electron capture, what happens is this atom is going to absorb an electron, okay? And that's going to cause it to produce a new atom. Now, remember, what's on this side is equal to this side. So 14 plus 0 is equal to 14. 6 minus 1 is equal to 5. Now you open the periodic table and you see atomic number 5. It's which element? It's boron, B. So we're going to put here B. You have to be careful because electron capture is the only one where the symbol, this one, is coming before the arrow. If you think that this looks like beta, you are correct. But during beta emission, the electron comes after the arrow, like this. in electron capture, the electron comes before the arrow. Let's move on and let you have some practice. All right, go ahead and pause the video and try to show the electron capture reactions for nitrogen and calcium. Now remember, during electron capture, you have to write the electron before the arrow, like this. You have to write the electron before the arrow, like this. Go ahead and pause and finish these reactions. Okay, are you done? All right, let's see. This number remains unchanged, and this number will decrease by 1. We're going to open the periodic table and see 6 is which element? Carbon has atomic number 6, so this is carbon. Next one, this number is unchanged. This number decreases by 1. We're going to open the periodic table and see which element this is. Atomic number 19 is potassium. Okay, so the answers are like this. All right, if you think that you've taken good notes and you're ready, you can go ahead and go to quizzes and you can put in this game code and get some practice, okay? Go to join.quizzes.com and put in this game code and send me your scores.